We are doing lesson 4.2, using laws of exponents. There are 3 laws of exponents. The first one is if you have the same base number and you're going to multiply them together, you can add the exponents together. So you can only add the exponents together if the bases are the same. If they're not the same, then you cannot use the rule. So since these two are the same, you're going to have m plus n, and you'd add them together. For the second one, you have 2 numbers that you're multiplying together inside of the parentheses, and you have an exponent on the outside. When that's the case, you distribute the power. So if these are both imaginary ones, so you have 1 times m, which is m, and 1 times m, which is m. So you'd have a to the m, b to the m. The most common mistake is that people try to distribute the m when there's an addition or subtraction sign in here, and you're not allowed to do that. You can only do that if it is multiplication only. So again, this is a very common mistake. If it's an addition or subtraction, you are not allowed to distribute the m to both parts. So don't make that mistake on the test. Law number 3, you have a power to a power. Whenever you have a power to a power, you multiply them. So I'd have m times n. Here's my first example. I'm going to start off by multiplying negative 3 times 4 together. I get negative 12. I have an x squared and an x. This is like law number 1. So again, I would add my exponents because my base numbers are the same. So I have 2 plus 1 is 3. I have a y to the third times a y squared. Again, this is a law number 1, so I add my numbers together. 3 plus 2 is 5. So my final answer would be negative 12 x to the third y to the 5th power. B, I have s t to the 4th power, the whole thing cubed, or to the 3rd power. Now B looks a lot like law number 2. So I'm going to use that rule where I distribute the 3 to both parts. You know this is a 1 right here, so I'm going to have 1 times 3 is 3, and 4 times 3 is 12. And that's my answer. C. C, I have negative x to the 3rd power, that's a weird 3, squared. And again, this looks like what rule? 1, 2, or 3? Well, to me, it looks a lot like rule number 2. The only thing is you have to remember that there's an imaginary 1 here, and it's negative. So right now, you have negative 1 to the 3rd power, and you have x to the 3rd. I'm sorry, it's actually to the 2nd power, if I write it down right. Sorry, because of this 2, right? But then you have x to the 3rd squared. So again, you have the negative 1 squared, and you have 3, the x to the 3rd squared. And you have to make sure that when it's a negative in front, that you are including that sign. So you're going to have a negative 1 times a negative 1, which you know is a positive 1. And then you have an x to the 3rd squared. Now, remember, you multiply. Power to a power, you multiply. So 3 times 2 is 6. So you have 1 x to the 6, which you can just write as x to the 6. So whenever you have a power on the outside, you need to think of the negative. Since it's a 2, you do negative times a negative. If it was a 5 out here, you would have a negative times a negative times a negative times a negative times a negative. So the trick is, if it's a power that's an even number, you're always going to get a positive. If it's a power that's an odd number, you're always going to have a negative. But I wanted to write it out and show you so you understood exactly why we were including that negative sign. And it's a common mistake on the test, so make sure you remember the even or odd rule. Even, positive, odd, negative. Let's go ahead and do example number 2. I have a to, let's see, u times u squared to the third power times, and it's going to be u to the fifth. So I'm going to look at the middle one first. We know that this is just u to the 1. But I have a power to a power, so I'm going to multiply. 2 times 3 is 6. So I'm going to have 6. And I have my u to the fifth. I have the same base number, and I'm just multiplying now, so I can add my exponents together to get u to the 12th power. Let's try b. b, I have 3x y squared z to the third, and that whole thing is to the third power. When you look at your laws, this one is like law number 3. Law number 2. You have to distribute the power to everything, including this 3 to the 1. The most common mistake with numbers on the inside here is that they go, oh, 3 times 3 is 9. No, remember, you are multiplying the powers together, not the base numbers. So you have 1 times 3. So you're going to have 3 to the third power. Again, it's not 3 times 3. That's a big difference. This is an imaginary 1. So I'm going to have 1 times 3, which is 3. 2 times 3, which is 6. And 3 times 3, which is 9. So again, if you notice, I didn't change my base numbers or my base letters at all. The only thing that changed were their powers. Now, you can simplify this right here. None of the variables you can simplify. So you know that 3 times 3 times 3 is 27. And then you have x to the third, y to the sixth, z to the ninth. And that is your final answer. Let's do example number 3. Example number 3, I have 3t squared times t to the third minus 2t squared plus t minus 4. I'm going to go ahead and distribute this whole thing to each of the 4 pieces inside. So I'm going to write it out because when you're first learning to do these, the most common mistake is you either multiply or add when you're not supposed to. And I think if you write it out like this, like I'm going to do, you'll see the difference, and then when you get really good at them, you don't have to do that anymore. Now, for this one, you're going to have 3 times my imaginary 1, which is 3, and t squared times t to the third, you would add your exponents together. A lot of people think because there's parentheses right here that you're going to multiply them. No, that's only when the power's on the outside over here. There is no power on the outside. So we're going to have 2 times 3, which is 6. I'm sorry, we're not multiplying, we're adding. I just said not to do that. Sorry about that. So it's 3 times 3 plus 2 is 5. So like again, like if it was a power, you're not allowed to multiply. So we're adding. So we're good. 2 plus 3 is 5. Then we have 3t squared times negative 2t squared. And we have 3 times negative 2 is negative 6. 2 plus 2 is 4. Again, you're adding them. Then I have 3t squared times t. So I have 3 times 1, which is 3. And 2 plus 1, my imaginary 1, is 3. And then I have 3t squared times negative 4. So I'm going to have 3 times negative 4 is negative 12, and I just have the t squared by itself. So my final answer when I write this out is 3t to the fifth minus 6t to the fourth plus 3t to the third minus 12t squared. And this is in descending order. 5, 4, 3, 2. So we're good. We wrote it in the correct format. Let's go to example number 4. I have A, letter A, and then we'll do a B, and then we're done. So we have A squared to the k power times A to the k to the third power. So I have a power to a power, so I'm going to multiply. 2 times k is 2k times, because this is really like multiplying them, right? K times 3 is 3k. So now I got rid of my power to powers first, and now I'm just multiplying them. So since I have the same base and there's no parentheses because I got rid of them when I did the power to the power, we can go ahead and just add them. So I have 2k plus 3k is 5k. And we'll do B. This one's really tricky. You really have to understand your rules in order to not mess this up. Now, you are going to be distributing, but it's not a power to a power because there's no number on the outside here. So all you're doing is x to the mn times x to the m plus n. You are adding these together. So we have m plus m, and we know our base number is still going to be x, so I'm just going to write that. But we're looking at our exponents, and we would add them just like we added the 2k and the 3k. So here I have m plus m, which is 2m. And you know that my n's are going to go away, so I don't write anything, because a negative n plus a positive n cancels each other out. Let's look at the next one. I have x to the m minus n times x to the n. Okay, so I'm going to add my exponents. I still have my base number of x. M doesn't have anything to add to it, so I'm just going to leave it alone. But again, my n's go away. So I'm going to have x to the 2m plus x to the m. And am I allowed to add these together? No, because we are adding them. We are not multiplying them. So that's like this rule way up here that we talked about at the beginning. You're not allowed to do anything like that. Okay? So you leave it alone. And this is my final answer.